Another requested video, sorting algorithms, the core date of data organization, bubble, merge, and insertion sort for your paper 2 exam. Let's have a look. Bubble sort. Slow but simple. Compares adjacent pairs, for example 16, 60 and 20, and swap them if they're in the wrong order. Repeats until it's all in order, and it'll keep on happening over and over again until no swaps occur during the bubble sort. So first thing it will do, it will compare 60 and 20. We want, if we're trying to get to ascending order, so 20 needs to be swapped. Then we'll check 60 and 95. 60 is smaller, so it will skip, it won't be no swap. Then we'll compare 95 and 45. 45 is smaller, then it will swap. Let's have a look at a bubble sort algorithm, and you can slowly see the larger number slowly bubbles to the top because they're swapping every time until there's no swaps done in a whole pass. So going across one time is called a pass, and it only knows it's finished is if a pass has no swaps. Exam tip: the largest value bubble to the end first. Always state how many passes are needed in your answer. So sometimes you might say how many, the question might be asking you how many passes are going to be needed. And the negatives of a bubble sort is it's slow, but it's simple. It compares adjacent pairs, and it will eventually get done, but on the last pass it has to double check to make sure there was no swaps. Next one, insertion sort. The way insertion sort works is it's like having a hand of cards. Build a sorted list one at a time, but inserting each item into its correct position within the sorted partition. So it will look at 50 first. There's nothing on the left of it. 50 is sorted. It look at 10. It'll move 10 to the correct position before 50. Then 40, it will put it before the 50, and the 30 it will put before the 40. It will pick up and imagine it moving across to putting each card in the correct place. Exam tip: more efficient than bubble sort on small or nearly sorted data. Always identify the sorted and unsorted partitions. So as it's going across the list, it moves across, and on the left side would be the sorted list, and on the right side would be unsorted. Let's have a look. Now the green is the sorted side and the gray is the unsorted side, and then much quicker it's sorted through everything cleanly and quickly. Let's watch that again. There's no point watching it again because it's already sorted. Let's refresh it and do that again. Start the insertion sort. The green side is sorted, right side is unsorted, and it quickly moves everything into position. Let's look at this example of insertion sort. So it's all one list, and the left side is the sorted section, and the right side is insertion, the unsorted section. Pick up the 3, put it in the correct position on the left of the 8. Pick up the 5, put it in the left sorted section, unsorted section, and with the dividers moving along as we go along the list. Sublist, sublist, and 2, put it directly in the correct position. 9, put it in the correct position. 1, all the way across, and 4 across. Now we have a fully sorted list. Okay, so that's insertion sort. Merge sort. The divide part. Normally this is done for you in the exam, and you have to normally just do this the combine part and putting it together. So the way the merge sort, as the name is the divide and conquer method. It's a repeated algorithm that splits the list into halves until single items remain, then merge them back together. Got the divide side, splits it all up until each of them is in a single item. Then the merge, conquer part, merge adjacent sublists together, comparing and sorting elements during the merge step. And the final merge produce one fully sorted. And number of merges is based on the number of items. Exam fact, merge sort is the most efficient on large dataset, but it's more complex to implement the bubble or insertion sort. Okay, so this is a list that we're going to use merge sort. Imagine these are all individual sublists. We've done the split it into individual lists. So then we put them into pairs. 24 and 71 we compare and put 24 down here, then 71. Then we compare these two, 42 and 89. Bring 42 down, bring 82 down, 89 down, 47 and 23. Put the 23 down, 47, 51 and 43, 43, 51. And because it's not even, there's one on its own, you just bring that down. Now we compare these two with these two. So a group of 2 and a group of 2, we combine them to make a group of 4. Compare the first item with this side, first item with this side, 24, 42, put 24 here. First item compare to first item here, 42, and then compare 71, 89. Now we look at 23 and 43. What's the smallest? 23. Always look at the first item in the list, and we drop the lowest number, 47, 51, 47, 51. And again, this is on its own, put it down on its own. Again, now we combine these 4 with these 4 to make a group of 8. 24, 23, put 23. 24, 43, put 24. 42, 43, 42. 71, 43, 43. 71, 47, 47, 71, 51. And these two can just drop down, there's nothing to compare to. And then finally 34 and so on. And finally, in an odd list like this, we still have to try to combine this list with that list. And we compare 23, 34, 24, 34, 42, and drop that down. Now there's nothing to compare these on, we can just drop them straight down in the order they are in. And we have successfully sorted our list out using merge sort. So you would have to write this in the exam in the exact order. Remember to use the numbers given, or if it's letters, words, you need to do it alphabetically. It's the same exact method, but use the data that's been provided. Okay, let's go down to the next. Here's an exam question example. It says, show the stages of bubble sort when applied to the following list: crime, bait, victory, fright, victory, nibble, loose. And if you look, bait is in the wrong place, and we can see victory is in the wrong place. So when we do the first pass, bait and crime get sorted, they swap, and then victory slowly gets to the end, and then nibble and loose are in the wrong place after that. We come across, and that gets swapped. So it's a loose and nibble, and then here is everything sorted now. So, but there's one more extra swap: bait, crime, fright, loose, nibble, victory, because bubble sort needs to do one more check to make sure that there is no swaps, and that will give us the final pass. Let's have a look. This is why bubble sort is quite inefficient. Even though there was no swap, it had to do one more pass. Okay, so merge sort question here. Complete the merge sort for the following data. So it's already been split for us, and we need to combine it. So combine it in from 45, 12 into group 2. 12 goes here, 45 here. That's correct. Minus 99, 100. Minus 99, 100 here. Minus 13, 0. That's correct. And then minus 27, 17 there. And then we combine these two with these two. 12 and minus 99. Minus 99 goes here. 12 and 100 is 12. 45 and 100. 45, 100. Remember, we always look at the front of the lists and we drop it down. Then we combine minus 13 and these two groups with these two. Minus 13, 27. What's lower? Minus 27. Minus 13 and 17. So it's minus 13, 0, 17, 0, 17. And then they did not group these two together. So let's see if they got all marks. And they've lost the final marks because they did not merge the last two. So out of the 4 marks, they only received 3 marks. This is a student answer. Example student answer. Okay, this question state why insertion sort is usually faster than a bubble sort when sorting a list that's almost in order, already almost in order. So with insertion sort, it makes fewer comparisons and makes way fewer swaps. And that is the correct answer. So you would have got 2 marks for that. Partitions. Describe the 2 part of an array during an insertion sort. As we discussed before, this student wrote one side is sorted and the other side is unsorted. You move the markers across. So the marker meaning the line going across as we're sorting it. There you go, correct. Insertion sort. Show the stages of insertion sort for the following list: 32, 12, 17, 10, 28. So that's the initial values. Then we look at 32, that's already sorted, so we can ignore that. Start with 12, that goes there, that's 1 pass. Then we look at the next number, 17, where did that go? That goes in between. That's the sorted side of the list, that's the unsorted. Then we look at 10, where did that go? Right at the front, sorted, unsorted. Finally put the 28 there, and that's a perfectly sorted list. And that's the end of this video.